What will it do? Yeah. Okay, so we are recording the class now. I'm going to post it into the Blackboard and our class website. Okay, so this, you have any questions for Chapter 9's homework? Have you used the template? Have you used the template? Chapter 13 is about return and risk and also security market line. Just think about what stock you're buying, and then just make you miserable.
K-Bio.
K-Bio. Let's just find it out.
How many times did that start making miserable, George?
3.
How did you say?
Oh, you did?
I didn't.
It made you miserable 3 separate times.
Right.
Yeah, go to finance. Finance. Now let's just use that one as an example. Okay, what's the name of this one?
K-B-I-O.
Yeah.
That one was terrible.
You have a friend like Helen is working for this company, so he got some inside information that, it's sort of legal. Well, I know it's legal, but they did it, right? With Helen.
Yeah, the CEO of that is the same guy who biked up the drug,
Right.
100%, that's the guy who's driving.
Yeah.
So they put him in, and then
Look
they
at it,
bumped
dropped $21 from, yeah, dropped.
It was $2 earlier this week.
Stop.
It was $2 a share.
Yeah.
Yeah. It had a horrible day, but it's still up like 900%.
Well, it started from $2,
It was a funny stock,
it's still $18.
It went from like zeros to 50.
I had a range on this stock today of like $125,000. I made $25,000 early in the morning, and then lost it all. It was down like $100,000.
This is a new company, right? So this is a new company, right? So because we need 5-year history. It doesn't, right?
Try Tesla.
Yeah. Okay. So Bruce say Tesla.
Yes,
I have a quick question. Chapter 9 homework there wasn't a due date for it.
Well, usually just give you 1 week just to work on it. Yeah. So have you finished it?
I mean, I'm part of the way through.
Yeah.
It's
Well,
due date,
I
I'm just gonna
received
finish it
actually
tonight,
from
but
almost everybody. I think.
Okay.
I haven't checked it yet, but I think.
there wasn't a due date on it, so that's just.
Well, usually I'll just give you 1 week to work on it. Okay,
Don't worry, Zoe, you'll pass.
so this is Tesla. Okay, so so when you're looking at the Tesla company, and then you know the history and you know a lot of things, but the thing you should also watch over, of course, is the price, right? And then you want to know when you put the money into Tesla kind of company or other company, and you care about not only the price but also the return, right? This is the most important one. There's another thing you should care about. You should care about the risk, right? So you want the stock is high return, give you high return back, and meanwhile give you very low risk, right? You want this kind of stock. Right? So how to measure return? You want high return stock. You also want low risk stock, right? So we all want this kind of stock, but how to just measure this kind of how can you tell this stock is a better one than like K-Bio?
Every stock is better than K-Bio.
Yeah, well, so far.
Not for the
So
guy who
far.
was on that last week.
Yeah, but anyhow, how to buy, how to check the return, how to check the risk. So you have thousands of stock to consider about. So you want the low risk stock and also high return. So first thing we should do is just to calculate the risk and the return. That's the first 2 moments of statistics. So how to do that? Return, we know how, right? So you know how much you bought it for, you know the amount of the dividend you received in the holding period, and then you know the price you can sell for. And then you just use the price you can sell for plus any dividend you received, subtract the price you paid for over the price you paid for. That's the return, right? And that's easy. You know the price, you know all the incomes, you can figure out the return. But what about the risk? How you can figure out the risk of Tesla? Is Tesla more risky than K-Bio? Uh, most risky one. I'm pretty sure there are other stocks more risky than PayPal.
Nope.
So far, but how to calculate the risk of the stock? Well, we know Tesla definitely has to be more risky than Walmart, right? Then why? We all know so. We say so. We think so. So no, no, it's not. Yeah, Walmart is doing well. You have to look at longer period.
Isn't it like the PGE rate ratio or something like that? Like
PEG ratio,
no,
PEG
like
ratio,
PE,
yeah, PEG ratio is to pick the undervalued stock. Now we're looking risk. What's the definition of risk? When you talk about the stock is risky, what do you mean? I'm afraid to walk over there. I don't want to be in the video. That's why I was so afraid to walk that way. Because I don't want to see myself, in the video where, so I'm trying to stay away from that. Huh? I don't think so, really. I really don't think so. Yeah, but it's on though.
Is it saved like a podcast? So I can rewatch it or no?
You can rewatch it.
Oh, okay.
Yeah. Anyhow, so what's risk? When we talk about risk, what we're talking about?
Probability of loss.
Probability of loss. You're right. Yeah. So when we say Walmart is more risky or is less risky than Tesla, means it's less likely to lose money from your investment in Walmart than in Tesla, right? You have to prove it. You just make the contest like this. This is your conclusion, but why is that? How can you just show me some numbers to prove it?
I thought the beta
Yeah.
was volatility, which I would consider risk.
Yeah, how
I
much is
don't
the
remember.
data? Yeah. Let's just use Tesla as example and compare Tesla with other companies like you are interested about, Walmart or other companies. Okay, well, let me just do this. Okay, so let's just do this. Just pick 3 stocks. It has to be the leading firms in the 3 different industries. And then let's just calculate the return and the risk of each stocks. And let's set up the portfolio with those 3 stocks. And then let's recalculate the portfolio's return and risk. And then you see the portfolio's risk will be lower than the individual stocks.
Let's try it on cash, please.
Okay, so the return we know is pretty easy to calculate the risk. Usually we use standard deviation to measure risk. Why we can do that? So what's standard deviation? Why we can use standard deviation to measure risk?
Well, that measures volatility, how far it's moving from some center point.
So yeah, because we care about losses, right? For example, this is Walmart return. For example, the mean is 10%, and then so we care. For example, here is 0%. We just don't want returns to be below 0%. If this is a normal distribution, and then for example, this is one of the stock. In comparison, there's another stock also give you 10% return. So which one is more risky, you think? Because risk means if it's more risky, we mean the possibility is to lose money is higher for the risky stock, right? So you see the possibility is just a shaded area. So the area of shaded area for stock 1 will be higher than the shaded area of stock 2, right? But you see, standard deviation is just standard. What's the definition of standard deviation?
Isn't it how far from the center?
How far? Yeah. How far from the center? One standard deviation. The definition would be What's the definition for standard? I really don't remember now.
60%
68%.
within, yeah,
68%,
68%.
for example, 68%. If it's a normal distribution, it will be 34% on one side, 34% on the other side. So this is one standard deviation. This is another standard deviation. This is the mean. So if it's a bell curve, and then one standard deviation away from the mean will be like 34%. Possibly the whole area would be 100%. What's the definition of the standard deviation? I don't remember now. Anyhow, standard deviation measures the spread from the mean, or measures the difference, measures the spread from the mean. See.
The measure of how spread out numbers are, its symbol is the Greek letter sigma.
Yeah, it's sigma.
The formula is the square root of the variance.
And we can see, you know, I'll show you. I'll show you using Tesla and Walmart and maybe another company and which one. And I can show you, and then I'll calculate the standard deviation of these three stocks, and I'll calculate the possibilities for the stocks to fall below 0% is how much, and you can tell. You can just compare and tell which one is more risky. Amazon, okay. Okay, so what you can do, okay, so we have three stocks. Or you can just go ahead and work on this with me. So we have, what do you think? So Amazon, Walmart, Tesla. So I'll say Walmart is the most, Walmart is the safest one. So the risk will be Walmart and Amazon and Tesla, right? Well, here just by standard deviation. So what I mean here is just standard deviation of Walmart will be lower than the standard deviation of Amazon. It will be lower than Tesla. So I'll show you and you see, and I'll draw the bell curve also using the real data from Walmart and Tesla. Let's first just do this. You can work with me. You can work with me on this. Let's just work on the Tesla. Well, you know, you go to finance.yahoo.com, and click on the price. And let's use 5 years data.
Wait, what did you click on?
Finance.yahoo.com, and then here, Tesla. And then click on historical prices on the left side. Okay. And then we want monthly stock return, should be 60 of them. So let's just look at the 5-year prices. Click on monthly, and then let's just go back to 2010, also November 24th. And then, so you see the price. And then let's just download to the spreadsheet.
Monthly change to June.
Okay, I open this in Excel. Okay, so you see, so this is Tesla's price. So this is Tesla's stock price. And then so we don't want the open price. We just want the adjust close price. This is the price after adjustment for the dividend. So we can just delete all these and change the title to Tesla. Okay, so this is the stock price of Tesla. Monthly stock returns in the past 5 years. Okay, so we can just continue working. Okay, continue working, and then so we want, and then we can just change, go to the right corner, and then get historical prices for change for Walmart. And don't need to change anything else. And then you will see the price in the past 5 years. And then you download it. Okay, the same thing. And you got the stock price of Walmart. You can just copy the Walmart price to Tesla. And then continue doing this for Amazon.
You just want to do it back to 2010, just 5 years?
Yeah, Yeah, it has to be monthly stock prices. Okay, so I'm done. So I'm done here. I got all the stock prices. So what I did, you see now I got all the data for the study. So I got 3 companies and stock prices from November to the 2nd of November 2015 to so we don't need this information. We don't need this. We could just start the data. We could just start the data from December the 1st to November the 2nd, 2015. So I got the data. So what I did, I went to finance.yahoo.com and then click on the historical data, the historical prices, and then change the date from today to 5 years ago, and then click, and then so I got this, and then I just download the data to Excel. I open the Excel sheet, and then so I delete all the data except the adjust close price. So I just put Tesla's and Walmart and Amazon all in one place. So here it is. And so you got it. This probably will take a while. Anyhow, so you got the price. Now the next thing you should do, because we cannot just tell from the price, because some of the stock price could be as high as Google, it would be like, or Amazon, it's like $600 or something. And also, they could be, so we can compare on the basis of return. So return should be comparable, more comparable. let's see, Walmart. So let's just calculate the return. Okay. So we want to compare price. We want to compare on the basis of return. So to get the return is very easy, right? Because you want to know the return in November, you just use you want to know the price. You want to know the return for Tesla from in October. You just use October the 1st price and then compare that with October the 30th or November the 2nd price. Just consider this is your just think about you bought the Tesla on October the 1st, and then so this is the price you bought it for, and just think about this is the date you decide to sell the stock. This is the price you sold it for. So, and this has been adjusted for the dividend already. So you don't have to add any dividend to this. So if you bought it if you bought it for $206, and you can sell that for $217, what's your return in this? So all you need to do is just to use this divided by the earlier price minus 1, right? Or you can use the price 217.5575 minus 206.93. Use the difference over $206.93, and that would be your return.
Wait, can you say that again? I'm sorry.
So you can use, because just think about this is the price you bought it earlier, and then you sold it later in that 1 month period. So you want to know your return in that period is how much. So you can just use this is the price you sell that for. Well, this is your profit, right? So in that month you make $10.82 in profit, but your initial investment is $206. So your return would be profit over this, right? So it's pretty easy. To figure out the return, you just use the end of the period price minus the beginning period price and use the difference divided by the beginning price. And then that will be your monthly stock return. So the first thing you should calculate is just the monthly stock return.
What's the first box? E2?
Huh?
You click on E2?
E2?
Yeah.
Oh, or you can just use the price. It's the same thing. Just you figure out the later price is how many times of the earlier price, and then subtract 1 with your return. Or you get the difference first and use the difference over the initial price. It's the same thing.
So B2 minus B3 minus 1, or B2 divided by
B3 and minus 1. And then you can just drag it down until like almost the last one.
Then will it always be minus 1?
Yeah, because you're using like how many times is your selling price. Your selling price is how many times of your purchase price. And then you can just drag it over for Walmart, and then you just calculate and see the command will be for the same. It's the same. So you got the return this way. Yeah, based on this, you see, we can just calculate the average return of Tesla.
Second page. Is that average return?
Huh?
Yeah.
Okay. Okay, so so let's just get the average, and then we'll get the risk. Okay, so, and let's just get the probability less than 0. Means losing money is how much? Can we do that? Okay, let's do that. Average is easy, right? Average is easy, and it seems like risk, because we can just figure out the standard deviation to do that. The math for average, we just add it all up and divide it by n, that's the average. So we don't have to do that. We can just use the average in Excel. And then Excel. And just drag it. The standard deviations equation should be, I remember.
Okay, wait, how did you do the average again? Sorry.
AVERAG,
Right?
and you just cover the whole return for the stock. Standard deviation should be.
Wait a minute, how did,
Yeah, this is the standard deviation equation.
our averages aren't matching?
Yeah. No? This is Tesla.
I think you go one more.
One more?
It's supposed to be 61.
Yeah, 61. Maybe.
Yeah, that's it.
There's no data.
No, but your equation was only 360. That was 62 where there's no data. I can't actually read that, it's so wide, but
Oh.
I got you in front of the camera. Oh, that's better.
Better,
Yeah.
See, just use the average.
That should be the 61.
She doesn't have anything in 61.
Huh? Oh, 61. Oh, sorry. You're right.
Yeah.
60 though.
Mine
Ours
goes
was to 62.
No, she deleted that
Well,
last.
I deleted December. I deleted November the 24th. The last observation was for December the 1st.
Oh, okay.
Yeah, that's
Delete that
probably
one.
why. Because we're looking at the monthly stock return, so the next one should be the. So we are actually just looking at the December 1st, 2010 to.
Okay.
Yeah. Sorry, so I deleted that one. Because there's not a whole month from now.
Okay, and then you deleted.
Yeah, I'm sorry. Anyhow, even though you are using 61, 62 observations, it wouldn't affect the results much. See, the average is just added up, divided by n, and then next we'll calculate the risk, because standard deviation measures the spreading from, from the mean is how much. So it's more risky means the negative spreading part of the spreading will be high, also will be large also. If it has the high spreading in the negative returns, so that means possibilities of negative returns will be high. So, we can just use standard deviation to measure risk. So the syntax for standard deviation is STDEV to calculate the standard deviation. Or, mathematically, since we have 60 observations and we know the mean, you just use each observation, subtract the mean, and get the square, add it all here. And just to add it up. So we have 6 observations, and then add it up, divided by 60. Divided by 60, and then that will be the variance, and then get the standard deviation, get the square root, and that's standard deviation. to do that mathematically one by one. But stdev would be the command for the standard deviation. Again, it's quite easy. You just type equal stdev, and then again just drag down. That's it.
Excel's really the greatest.
Yeah, it's in Tesla, but however, if we draw the graph, I'll draw the graph and then let's see. Okay, so for Tesla, the return on average is almost 5%, and the standard deviation is almost 17%.
It's the same for Walmart.
Yeah.
Which,
You see, what we care about, we want the probabilities to be low. We want the probabilities negative to be low, and that means it's less risky. So you see, Walmart standard deviation is lower. Means spreading of Walmart is lower.
That means it's less risky.
Yeah. Well, let me show you the graph. The normal distribution for this. You see, let's do this. X. Let's just assume it's normal distribution. Let's just start from. Yeah, well, let me just do this first, and then I'll show you how to do that. Okay, just create a number. Let's just assume it's a normal distribution, and Gerald knows this, right? So let's just assume this is normal distribution, and then this is x. For each of the x number, x is the stop returns, and you can find its normal distributions density functions fx value, right? So the equations for the normal distributions fx function is very complicated.
How did you have the negative point or negative 0.3?
Well, I just started with this number. I may change it later, which is something I just typed.
Oh, okay.
I just want to create, what I'm doing here, I just create a series of x values, and then I'll find out in fx the function value, and then so I'll draw this curve. Because I just picked the x value randomly, not randomly. Anyhow, I picked this x number, and then assume this is a normal distribution, and then calculate the density functions fx value. Yeah, and then so I can draw the curve, bell curve. The command is called nrm.dist. This is the command, normal distribution, to calculate the fx. And the function of fx function is very complicated. I'll upload them to our class website. But anyhow, it has normal distribution. Also, it has to calculate the cumulative numbers for that. Anyhow, say this is the x. For each of the x, there's a corresponding function value. The mean is standard deviation. For cumulative, since we are calculating the function value, so put it 0 or false. Or 0. And then you have to define, you have to fix the mean, and also has to fix the mean.
What did you just do there? What are you doing when you do that?
Well, I'm calculating the function value.
Or what did you just put dollar signs in there?
Yeah, that's just to fix, because I'm using the same return, every return, and also the risk.
Oh, so it doesn't
So,
change.
yeah,
Okay.
so I'm just fixing these two numbers, and then changing only the X numbers. Okay.
So do you have to fix 0 then too, or 0 is 0?
What 0? Yeah, it's all 0, because I'm calculating the function value. Because 1 will be calculating the cumulative function, the fx, right? So this is the density function, and this is cumulative function for a normal distribution. And this is just used to calculate the probability for normal distribution. Right? So, okay, and then so we can just drag it down. Last rule, don't worry. Now let me just show you, and then I'll go back to the concept again. Yeah, see, this is Tesla. Can actually add more observations.
I have a good question.
Yeah, go ahead.
Did you put, on the return, we put on the final formula?
The final number is 0. The zero is for fx function, the density function. Now I'll show you in a second. See, so I got all the data, and then I can just put everything into one graph. Let's see. This is a graph. See, so which one is which? Should be Walmart. Yellow should be Walmart. Tesla should be this. And then the middle one should be Amazon. So, so which one is more risky? Tesla, right? Tesla is more risky. And then Walmart, you see, is more stable. It's around the center. And it has spread. Well, you won't make lots of return like Tesla did. But however, you see, but you see, the possibilities to lose money with Tesla is a lot higher than Walmart and Amazon.
What graphing function did you use? Just scatter plot?
Scatter plot, yeah, using the line.
Okay.
Yeah. Well, and then let me just finish it first, and then I'll show you how to do that. Probability is less than 0. Okay, let's just calculate it. Still the same function, but however now, because we want to know the probabilities to be lower than 0 is how much for each stop. So in this case, this is a normal distribution. Just think about this is the normal distribution. For example, this is minus 10%, and you want to know the possibilities to be 0%. Because you want to figure out the possibilities to earn negative returns how much. So you want to calculate this normal distributions and the area is how much. Because the area will be the probability. Well, this is just the features or properties of normal distribution. It's very easy to do that. Well, mathematically, using Excel, you can just use norm.dist, but change the last input from 0 to 1. 1 will be just calculating the areas on the left side of x values. And if it's 0, it's just calculating the fx, the density function, calculating when x equals to 0, its function value, or density function value is how much. But if it's 1, it calculates the area, the probabilities. So in this case, it's 0. The change, the last input from calculating true, yeah, true this one. Okay. Okay, so this is result. So you got, for Walmart, you got 45.84% possibilities to earn negative returns. Is there any mistakes I was doing here?
Walmart should be the smallest, right?
Yeah, but Walmart, the mean is so low. It still should be smallest one, right? Something's wrong, right?
Well, the graph,
Yeah,
the little short one was Tesla. Amazon was the one in the middle, and Walmart was the tall, steep one.
yeah, I think so, right?
I must have misunderstood that earlier, because but yeah, I regraphed it with the titles, and
Oh, okay.
it actually showed, just like you just did. I think if you graph it now, it'll show you which one's which.
Yeah. See, it is. See, this one is Walmart. The tall one is Walmart.
Yeah.
Yeah. So the probability I just calculated is just the 0% when 0% is just in that area. How much?
And can you show that formula again?
You see, so anyhow, from the graph, it seems like Walmart has less spread, but however, its mean is pretty low. Yeah. See, you just change x, fix x as 0. So you're just calculating the area for on the left side of 0. So on the left side of 0 means negative returns. So if you buy Amazon, you got 37% probability to make negative returns.
And then you do true for the cumulative?
Yeah. Or 1.
So 3.
Or change it to 1 should be fine. The same, yeah. 0 is for the function, density function. So you can just do this, so basically you got the return on average and you figure out how risky it is. And you can change it to any number. You say you want to figure out the returns to make like, for example, you want to earn about 5% return. So how can you do that from Tesla? Let's say 10% return. What do you think? Possibilities to make 10% return for Tesla is how much? But greater than 10% will be on the right side. So you figure out the returns on the left side of 10% and use 1 subtracted, and that will be the returns on the right side. So yeah, see, if you to make 10% return for Walmart is only 3%.
Why do you go 1 minus?
Well, see, for example, the mean is 5%, and you want to know the returns equals to 10%. So x equals to 10% now. But using the function, what you got is just the areas in the shape,
So you're
in the shaded area. But however, you want to know this part.
Yeah, I got you.
You want to know, so 1 subtract this area would be your, that dot would be your. You want to know your possibilities to make returns higher than 10%. So you want to know the right side.
Makes sense.
But the equation is only for the left side.
Right.
Yeah. So you can do a lot of analysis using, you assume first it's normal distribution, but it's not. Because stock returns do not follow this kind of normal distribution. In fact, it has fatter tails. They got more chances to be on both sides, extreme numbers, to give you some extreme returns. So it's not normal distribution. But anyhow, make it easier, we just assume it's normal distribution, and then so you can figure out the probabilities of any numbers. You see, if you buy Walmart and you can get rich quick, but however, for Tesla, you can make 10% return with very high possibilities using the 5 years data in the past 5 years. anyhow, yeah. Let's still just go back to the 0%. Let's still do that. So, okay, so what I did is I first just define, well, just give some numbers for x. So, and then just calculate this function distribution. Normal distribution is density function value. So I can draw this bell curve.
So if I wanted to find what the probability of making a positive return is,
Yeah.
I would put 1 minus in front.
1 minus that. So you got is probabilities to lose money, right? So you just use 1 minus. And that will be your possibilities to earn money.
Right, okay.
Yeah. So that could be any numbers.
Right.
Yeah. So what I did is first just give numbers for x. So it should be a wide range of numbers. It should be fine. The distance between the observations should be like very small. And so you have a nice graph. And then to figure out its density function, using NRM.dist. And the first input should be the x value. And then the second input is just the mean. The third input is just standard deviation or risk. The fourth input is 0 for function value. We want to draw the graph, and you calculate the fx, the function value, the density function value, the distribution density function value. And then so, well, if number seems odd, but for this x equals to -0.5, and then density function value is just this. And then you draw the graph. And the graph is this. So you see, which one is better from this graph?
Amazon.
Yeah, well, usually if you read the textbook, and then the answer for which one is, the better one, it's called Sharpe's ratio. Usually what they do is just using the risk over the return, or return over the risk, doesn't matter. You get the ratio, this is called, I think this is how it's called something else, but it's similar. Sharpe's. Yeah, you just use the risk over the return, so you just unify the return per, you just get the risk per return is how much. So it just says your risk is 3.5 times of the return for Tesla. And then the lower the better. Because you're using the risk over your return. So it just says per return, per 1% return, how many times of risk you're facing. So the lower the better. So you're right. In this case, Amazon should be better because for 1% return, you're facing about 3.13 times of risk. So, but for Walmart, even though its standard deviation is lower, but its return is low too. Based on the Sharpe's ratio, Amazon is the best one. And based on this, probabilities to be still Amazon is the best one. This is probabilities greater than 0, and then it has highest number. So for individual stocks, even though mathematically to do this is pretty complicated, but so you see, okay, so you just calculate all these numbers. It's the same thing. So between Walmart and Tesla, the only thing changed is just this mean and also standard deviation from Tesla's to Walmart. And Amazon is the same. And then draw the graph.
How did you, I'm sorry, I was trying to make my graph. How did you do the Sharpe ratio?
Well, it just return risk over return. So it just said for 1% return, what kind of risk you face, the lower the better. So, well, based on past 5 years, Amazon is the best performer among the 3 stocks. And I'll post this into the class website, and so.
Oh, good.
Yeah. Does that make any sense? It does, right? So, we know, well, Amazon is a good company and you guys don't like Walmart. You think Tesla is a good company. And then, you guys are right. But however, you have to just demonstrate it. Use some numbers to prove your point. And then this is the way to do that. And for example, somebody comes to you and wants to buy a Tesla and you can just tell him, like, you may lose money with possibilities of 30-something%. And then, yeah. Huh? Yeah. Does that make any sense, Paul?
Yeah.
Yeah.
He's making fun of my stock pick. Said I should have done this for K-Bio.
But it has to have at least 5 years of stock returns to look at, to check it out.
That's not the
If it
trade.
doesn't, you shouldn't buy it.
Huh?
If it doesn't have 5 years of data, you probably shouldn't buy it.
Or you can, no, this is a new
Thanks,
company, you shouldn't buy that, definitely. That's right, you shouldn't buy that. But anyhow, this is the way to do that. And then, so it's pretty easy, right? It's pretty easy. Yeah, and the second thing, that's not all. That's not all. But the second thing you should do, you should consider about you should consider about portfolio, right? You want to hold Tesla, or Walmart, and Amazon. But is that a good choice to do that? What do you think? Individually, you want to hold Amazon. But however, you probably want to invest in all 3 stocks, right? So is that a good choice? What do you think?
I would say wrong.
Huh?
I would say wrong.
You want to take out Walmart? Let's try something else.
Well, this only takes into account
The stock price,
history.
the history, yeah, but
I mean, well, we could do this with like
but
you could do it with a pager, a beeper manufacturer. Maybe they had good years, the beepers are no longer relevant.
And then the market could take a big dump in a week. And then, it doesn't matter what you have.
But most stock analysis is just based on the stock prices. What else you have?
Well, I just mean like Walmart is becoming kind of an obsolete,
Yeah,
business model
yeah.
as opposed to something like Amazon. So even though Walmart may have done well in the past with, businesses like Amazon coming up, they're stealing their market share. So past data is not necessarily, indicative of what future data may be.
But he's saying it's going to be more high risk than to invest in Walmart.
But see, if you're going to invest in the stock market, people even tell you, well, in the past, since 1929 till now, stock return is like 10% every year or something. They still tell you stories like that.
Not for K-Bio.
They'll be telling us.
Yeah. So any questions? So you just need to get familiar with it. Well, in the exam, I will ask you just to calculate the return and the standard deviation and correlation also. But I won't ask you just to run I think there's a homework I'm asking you just to do that. But in the exam, it's easy, in fact. It's take home, so it shouldn't be a problem. Yeah, so we just understand the concept. We understand the concept is, you want to figure out the possibilities to lose money. So you just do this. You can just calculate it.
You said you will upload this to the website?
Yeah.
Yeah, okay, cool.
I do that, yeah. But so this chapter should, you're familiar, just get you guys familiar with Excel. Get you guys familiar with Excel. And then normal distribution, you all know what normal distribution is, right? Normal distribution? Gerald, can you explain to us? Because you're a math major.
I would tell them.
Huh? You see,
It's that.
yeah, I see. This is normal distribution. You see, the standard deviation from the mean representing the probability. But if it's one standard deviation away from the mean, and that means one standard deviation away from the mean on one side, it means 34%.
Right. What Todd said earlier.
Yeah.
Yeah.
And then if it's two standard deviation away from the mean, it would be 95% or 90%, I forgot, either 90% or 95%, I don't remember. is it?
95.1.
95.1, okay. Yeah, you see, this is just a distribution, normal distribution, it's bell-shaped. Yeah, but however, the real market is not normal distribution, it has back tails. It has back tails, means it could be lower than, it could be lower, it could be higher too. Those extreme numbers could appear for stock market. Yeah, yeah.
Is that because it's artificial?
Huh?
Is that because it's manipulated?
Well, just actually, how the stock market is performing, and then how each stock is performing is still, it's still still under study. So, and also because it's so complicated, the market is complicated. So it's just random, right? The distributions in the stock market is just random. But anyhow, but usually if you look at the textbook and we're just assuming it's normal distribution, so we can just use the properties of normal distribution, apply that into the stock market. So we can just make conclusions like this. But anyhow, this is this. Well, the second part would be, you want to set up a portfolio, so you want all three of the stock in your portfolio. So is this a good idea? So how can you find out? We all know that you shouldn't put all the eggs into one basket, and you shouldn't just invest all your money in one company. You should spread it out, right? But how? Yeah. So usually you should just invest in different industries, right? And then, but how you can find out is a good portfolio. You see, for example, we have 1/3 in Tesla, 1/3 in Walmart, and 1/3 in Amazon. And then, so we have the portfolio. So you think it would be better than like just holding only Walmart or only Tesla or only Amazon?
Yes.
Yeah, but prove it. Let's just say, let's have a portfolio now. Okay, let's just say we have a portfolio 1/3 in each. Okay, so that means our return should be so if we have a portfolio of the three, so our return of the portfolio should be the average of the three, right? Yeah. And what about the risk of the portfolio?
It's by square. And they're gonna end up being square, the factor squared,
Huh?
or the,
Well, the average of the portfolio is just the average of the three stocks, because it's 1/3 in each, right?
right,
Yeah, so just 1/3, multiply this by 1/3, and so it's just the average. Or, it shouldn't be lazy, it should be 1/3, 1/3 of this. Yeah, so it should be 1/3, because the percentage in Tesla, the percentage plus the percentage in Walmart plus the percentage in Amazon. But the risk is still standard deviation. So if we know the standard deviation of Tesla, Walmart, and Amazon, so how can we get the portfolio's risk? Is that just the average? Gerald, what do you think?
Yes.
No.
No, I don't know.
No, right? Since you have the portfolio got 130 each, right? It's just how can I say this? Okay, for example, Todd and I, we teamed up in a project, and then we both contribute a lot to this project. So we better than like, well, because it's kind of effect of the group, and it should be higher than like individuals, right? So what do you think? Todd, what do you think? The equation, so I have to clean up this because I need the whole space to write down the equation. That's why. The equation of portfolio is this.
You said
Oh, yeah. Nine.
it's just
That's
I know there's a shortcut.
Yeah, I see. Huh?
I know there's a shortcut.
So this is just correlation. What correlation is, just like you have a stock, for example, this kind of price going up and down every day, and there's another stock which is working, also going up and down every day, but it's just moving opposite way. And if you have those two stocks together, it will have a very stable return, right? You have something that just cancel out. It's just the Paris attack while just causing the stock market to fall. But it's picked up by the stocks in US. So if you have investment in those markets, so it probably doesn't hurt you at all. But however, if you invest only in Paris, you probably will lose lots of money. Just this kind of thing. You also have some kind of correlations in stock moving just along, moving together. So another stock goes up, it also goes up, goes down, also goes down. And if you have stock of these two stocks, and it doesn't make any difference at all, it just like make it more higher and more lower together. So you see more volatile, your portfolio will be more volatile. But this portfolio will be very stable. It's just like return is always very high, no matter what. Right? So the correlation of this would be like -1. This is -1. So the two stock in the portfolio will cancel out each other. And for this, the stock return, the correlations will be +1, which is like they all goes up together, it goes down together. Most of the time, the correlations will be between -1 and also +1 correlation. But you just have to consider correlation. For diversification purpose, which one is better?
For what?
Diversification. You want to diversify.
Then you want
You want negative, yeah, you want -1. So you want returns to be positive and always positive. So for this, actually, you just make it more volatile. You lose money if you have portfolio like this, you'll be losing more money. So we need to check correlation. So this is the equation for the 3-stock portfolio. So we have to check correlation.
What is the W? That might be a dumb question.
W is just
Or the omega.
weight or percentage. In our case, just 1/3.
Okay, wait.
Yeah. It's just percentage in each of the fund.
So how do you do this on Excel?
In correlation, let's do correlation. What do you think Tesla, Walmart, I'll say Tesla and Amazon and Walmart probably correlations are pretty high, right? Because it's all retail industry, not retail. Tesla is probably not much correlated with Walmart, right? Let's see, correlation, Tesla and Walmart. What do you think? What do do you think?
I wouldn't think it'd be much.
It just syntax is quite easy. CORREL. CORREL correlation. And then array 1, the input is array 1, array 2. Array 1 is just a stop return of stop 1. Array 2 is just a stop return of stop 2. Say Tesla and Walmart. So stop return of Tesla, go back to the return. How much?
Zero 85.
85? Not high?
No. That's what I got.
Tesla return.
Yeah, Walmart return. Well, I got negative 0.08. Well, it makes sense.
That's what I got. 0.085. It's probably the same. I mean, it was,
The order of the stop doesn't matter. Okay, so they're all negative. Strange, right? So that's what I got, right? That's what you got too? So, okay, so we got the correlation. Okay, so got it? And then we'll plug into this equation and we can just get preferred integration. Even though it's complicated, but however, it's just, we got everything already. So first it should be SQRT, right? And then just each of the number. Or let's just don't do that. Let's get a variance first, and then standard deviation. However, there's no one command to do that. You just have to do that. Just 1/3. 1/3 just a weight, and then standard deviation. Standard deviation of Tesla plus the second one. We're almost there, almost done.
size, but
Okay, so that's a very long.
that way, there's really no,
So standard deviation, this is a risk. This is just, so anyhow, so this is a standard deviation, and then we can just create another function for portfolio. Well, if the graph looks good, and then the calculation should be right. This one, and where's let's draw the graph again. The yellow one is the portfolio. Yeah, it should be right. I think my calculation should be, it is right. So it's in the middle. It's not the best. The portfolio is not like pink. It's not like its performance is the best. The portfolio means what? The portfolio means like it's everything averaged out. You got some mediocre results. That's portfolio. The reason just because like what has happened to you is like you pick one stock, it just drag the whole portfolio down. So if you have a portfolio like this, it will just average everything out. If you have only one stock, and I can show you, you think you're doing really bad, you cannot beat me, really. I think I showed you guys before. I was buying the stock. Okay, so I was buying this stock here.
Please remove that.
So this one, so I was buying, one of my students was telling me GoPro is a good stock, so I bought it at the beginning of the semester and see how it is. Well, I think I'll be broke by the end of the semester. So see, so this is me. 57. I started with $500,000 like everybody. I don't think anyone would lose so much money like I do, so don't worry.
Ron James.
Right.
I was making 18% return today. But however, even a week ago, it was still above $100,000. I think it was showing you guys. So if I put all the money into this stock, so it's almost wiped it out from the market. So, but however, if I have Helen stock, it's probably the best. It will be the star of the whole market, right? But it's hard just to run into the worst one, or so. But if you have a portfolio, you just get the average result. Not the best one, but won't be that bad. So that's the purpose. That's the purpose to set up a portfolio. I only have this stock. I put it all in. So I think before the end of the semester, I was probably that's
Good thing you didn't short Apple.
Huh? Well, that's another one. I did. That one was doing pretty good.
I made 30 grand.
See this one. Yeah, this one is like 140,000. But this is start. Well, the trading start for this one is just the end of August. End of August at the beginning of the semester. So this is shorting Apple and also longing Google. So it's not that bad. You see, the portfolio is not like the best performer out of these three stocks. It's just average out these three stocks. So even the Walmart is by so far by this graph is the worst performer out of the three. But your portfolio will be like doing better than the worst one. Your portfolio will be doing worse than the best one. In your portfolio, you just average out. You won't lose money that much. You won't lose money. You won't make money that much if you put all in Amazon. That's portfolio. That's diversification.
You can hedge it, right?
Huh?
Like a hedge fund, you can hedge it with options.
Well, that's different.
Yeah.
Yeah, that's another thing.
That's what normally.
Yeah. I think I did it right then. So this is, you should get the correlation, and then we're just using the equation here. Yeah.
I got it halfway through.
The equation would be like, say, standard deviation of the first stock. It's just here. It just, you see, the number is just this. Because it's all 1/3 plus the second stock. You see, we're just using the equation. This is the equation, just plug in the number. The weight will be 1/3 in this case, and then this is just correlation between the first and second stock. You just using COR to do that. And then you see the correlation. Well, let's calculate the ratio, Sharpe's ratio, which is standard deviation over the return. So you see the Sharpe's ratio, you want it to be as low as possible. The Sharpe's ratio is 2.3 for the portfolio in comparison with the stocks. The three stocks are here. You see, so this is the lowest one. The lower the better. So for 1% return for the portfolio, and then your risk is 2.38 times, and which is the lowest one in comparison with each of the stocks. So, yeah. Now you guys are lost. Where you start just to feel you're lost.
The correlation, I've got a question.
Yeah. Please ask questions.
Is that a percentage? What
Correlation is between -1 and 1. The equation of correlation, the math equation is this. The correlation is between -1 and 1. It's just like, for example, you have you and Todd, right? The correlation between you two, the lifestyle and everything will be very close, but very similar. In comparison, like you and me to compare, and then the difference will be great. Yeah, so correlation is just like this. You're comparing stock with another one. If it's Target and Walmart, the correlation will be high. If it's a Tesla and Walmart, it will be low.
Okay.
Yeah, the math equation for correlation is this. Covariance, stock 1 and stock 2. The standard deviation of stock 1 and stock 2. And the covariance of stock 1 and stock 2 is I think it's over n. So this is the mass equation. It just measures the co-movement of the two stocks. If the two stocks, one goes up, the other one also goes up, and then the correlation will be high. If one goes up and at the same time the other stock price will fall, and then the correlation will be low or negative. And we want for diversification purposes, we want negatively correlated stocks.
Okay, so negative means that it's not correlated.
Means
Means correlated, but however negatively correlated.
Okay.
It means it's just like this graph.
Okay.
Just like this graph, one goes like this, and the other goes the opposite way. So yeah. So that's correlation. So you see, these three stocks are all negatively correlated, and that means it's good. Means it's a good stock to put into your portfolio. And then since you have to consider correlation, because you know, if you have stocks moved together and then it doesn't have any diversification effect, but if they move opposite to each other, it does cancel out a lot of effect, negative impact. So it has this kind of diversification effect. So you see the correlations, well, the equations for the portfolios, variance or standard deviation, consider the correlations between the stocks, between the two stocks. So see, this is so that's why you should diversify, right? So see, you diversify, you wouldn't have losses like too much. You won't have too much losses. Yeah, you see, so your Sharpe ratio has been reduced. So this is good, and also your standard deviation is lower than just holding one stock. Well, let's calculate this too. The probabilities for this. What do you think? It should be lower than Amazon or not? Okay, so just x is 0 and mean. This one. Deviation 0. Oh no, it should be 1. It should be 1. Yeah, it's here. It is, right? So if you have portfolio, your chances to lose money is 34%. You can reduce your, well, not much of the effect, but still, so you got less chance to lose money, which is the thing you really want to avoid. So see, that's why you should diversify. Yeah, you should consider more stocks to diversify. Not only 3, you should have say 8 stocks or even 20 stocks. So, but still, when you're calculating the portfolios, if you have 20 stocks, you have a really long equation to figure out the portfolio standard deviation. You have to consider each pair of the stocks in that. So where did you guys get lost? And then
I was good all the way until
portfolio. The portfolio.
No, I was good through correlation. But after that, I got lazy.
Yeah, well, after that, you're just using the equation to do that.
I got lazy. I didn't want to type that in.
Yeah, well, I can go home and work on it and post it. And next time we'll study, well, everybody is rational. Then we will go back to the concept of beta. It's easier than this. This part is really difficult, but as long as you understand why we should diversify and you can see the real effect of diversification, it will be fine.
If you could post this so that we can follow the
I
formulas
can
and go back and just retrace it, that'd be very
I'll make it nicer in Excel form. But however you see the effect, you see, what we're doing, right? Because individually, you evaluate the stock. And however, we all have portfolio. When you have portfolio, you have to consider correlation. And basically, the effect would be you have less chance to lose money with portfolio. And we didn't define the portfolio that that optimal. We just set it up very randomly. Yeah. I'll go back into that. I'll post the website, post it into the class website as well. Yeah. How about we just start this stuff here? I'm going to assign some homework, but however, it won't be due until like 2 weeks from now. Is that okay? You don't have to worry about it. Have a great, folks. Have a great spring. Not a break. Thanksgiving break. I'm going to be cooking hot pot for the Chinese students here. Yeah, we have about 10 Chinese students. They all come to my place. We're eating hot pot.
Oh,
yeah. No turkey. No turkey.
Adios, amigos.
Huh?
Said adios, amigos.
I did. I got yours. So you handed to me. Couple days ago,
It's basically the same thing. You do those
I'm pretty sure this is okay. Oh yeah, sorry for that. Because I'm still using it. I thought for some reason I know I had.
You're in big
You?
The hardest one to think of. Well, you do the same thing. Again, you're choosing. You do the same thing.